energy will be happens. Mainly one is mainly to the friction in the pipe or due to the viscosity of the fluid, the losses happens in a pipe when the fluid is flowing through the pipe. That one you're going to call as the major losses. Suppose when the fluid is moving like that, suddenly some fittings will becomes. That time what will happen? The velocity of the fluid will be changes. The direction will be changes. That time also the losses will be happens. That one you're going to call as the minor losses. Minor losses means what? Due to the fittings, like bends, like elbows, did like the sudden expansion, sudden contraction. Suddenly the fluid, the velocity will be changes. The direction will also changes. In that time, the losses will be happens. That losses we going to call as the minor losses. This is about the theory part of the minor losses. Now I am going to explain how to conduct the experiment. First, we have to on the mains. First we have to on the main. Later, we have to open this delivery valve. Before that one, first we have to confirm that which experiment we are going to carry out. Means here 4 experimental setups are there. This is the first experimental setup. What this is, the diameter is changed from higher diameter to the lesser diameter. This one is going to call as the sudden contraction. This setup itself is the one experimental setup, sudden contraction. This is the one experimental setup. To find the pressure at these two positions, different pressure tappings are there. Later, the second experiment is what? Sudden expansion. Sudden expansion means the diameter is increasing from smaller diameter to the larger diameter. Next, the bend is there as well as the elbows are there. Now, first we have to decide which experiment we are going to do, whether the sudden contraction or a sudden expansion or the bend. Suppose we are planning to conduct sudden contraction experiment, make sure that all these pressure tappings should be in the closed position. All the pressure tappings should be in the closed position. Once you make sure that all the pressure tapping is in closed position, which experiment you are going to carry out, which experiment we are planning to do that, you what? On that pressure tappings, just you on that pressure tappings, remaining all pressure tappings, all settings pressure tappings must be closed. Now on the motor, using this valve for different flow rate, conduct the experiments. By our guess only, by rotating this control valve, this is also going to call as the delivery valve. This is the pump, this is the pump, this is the suction pipe, this is the delivery pipe. So this is the delivery pipe for the pump. That's why you're going to call as the delivery valve, and also we are going to control the flow. That's why you're going to call as the control valve. And these pressure tapping valves we're going to call as the ball valves are simply a valves or pressure tapping valves. Just the name is given different names according to the valves. This valve you're going to call as the ball valves. Once this ball valve or a pressure tapping valve is opened on the pump, for the different flow rate we have to take the different readings. For one flow rate, you collect the data from, means you collect the pressure measurement from this YouTube manometer. This YouTube manometer gives the pressure difference between the sudden contraction, between the larger diameter as well as the smaller diameter pipe. From this one, we are going to take the pressure difference, and later for the known amount of water rise, we are going to collect that. We are going to collect that height from this tank. This tank we are going to call as the measuring tank. Also, we are going to call as the collecting tank. But this tank containing a scale, that's why we are going to call as the measuring tank. For a 10 centimeter height, here the scale is there in centimeter. The unit is centimeter. For a 10 centimeter height of collection of the water in this tank, how much time is taken? That should be taken. Only the two readings is taken. One is for the known height of water. For example, 10 centimeter of height of water, how much of the water is collected in the measuring tank with respect to the time should be taken with the help of the stopwatch. Later, this YouTube manometer, we have to take the pressure difference. You have to take what is the pressure difference is there. That one we have to be taken. Only the two readings have to be taken. What I explained the procedure, now same thing we are going to conduct the experiment. I will take only the one reading. The same thing is done for the remaining the one experiment, one reading. The same thing should be done for the different experiments. For the next set, for the next experiment means what? Sudden expansion. That time what you have to do? All the pressure tappings should be closed. Only that particular pressure tapping should be on. Suppose we are going to conduct the experiment on sudden expansion. We have to open only that particular pressure tappings. Remaining all pressure tappings should be closed. The procedure will be the same thing. One set of trial I am going to show, and the same thing, the calculation is also shown in the next part. Minor losses as water flow measuring devices. During the first reading of all the experiment, we have to remove the bubbles. Just opening these valves for some seconds. When after on the pump, the bubbles will be comes out. After bubbles will be comes out, take the readings for the more accurate values. Now the experiment we are going to conduct, the mains is on. I am going to on the pump. Okay. Before running the pump, I am going to once again ensure that which experiment I am going to conducting. Now I am trying to conduct the already explained. That is what sudden contraction experiment. So I only open this one. The remaining all pressure tapping valves are closed. Almost the settings is over. Just I am going to on the pump. Later using the control valve, I will give some discharge. First, for the first reading, I will remove the water bubbles. Later, I will take the reading for only the one trial. The pump is closed. I give some discharge. Now I will going to remove the water bubbles for the first reading only. Here you can see that what the bubbles is there, those are bubbles is come out. Just you run 20 or 30 seconds by opening the valve. What are the bubbles present in the valve, that will comes out. After the bubbles comes out, make sure that this valve should be closed. Otherwise you won't get the readings. Make sure that this valve should be closed. Otherwise you get the wrong readings. Now only already mentioned, I have to take only the two readings. Here you can see the pressure difference is there. In the right side lane, the mercury level is 4 is there. In the left side lane, the mercury limb is what up to 5 centimeter is there. In right side lane, the mercury level is 4 centimeter. In the left side lane, the mercury level is 5 centimeter. So the total height becomes the 9. 5 plus 4 is the 9. This is the pressure difference. This is the head between those two tappings. Later, here we are going to close the valve. First we have to close the valve. This one you are going to call as the butterfly valve. Close this valve. Here the water level is rising here. The water level is rising. Let it comes to the 10, position number 10. Then using time watch, stopwatch, I am going to measure how much time will be taken from 10 to 20 seconds. Using stopwatch, I am going to calculate, I am going to find out how much of the time is taken from 10 to 20 centimeter. Means 10 centimeter. Okay. Now I have taken the reading. Totally two readings I have taken. Only one is the YouTube manometer reading, another is the time taken for 10 centimeter height rise of water in the measuring time. The same thing, the experiment is repeated. Just change the flow rate. Just increase the flow rate. Now we conduct the experiment as usual. Take the two other readings. Means one is the YouTube manometer reading, another is the time taken for rise 10 centimeter of water. Okay, now we will going to discuss the calculation part of this experiment.
How to conduct the experiment is already explained. Now we will going to discuss how to calculate come to the calculation part. Okay, the experiment name is minor losses in flow through the pipe. This is the manual that is available in the department library as well as in the FM lab, in fluid mechanics and machinery lab also. So this is what we're going to call as the sudden enlargement, means the diameter is changing from smaller diameter to the larger diameter, and the sudden contraction means what? It is changing from larger diameter to the smaller diameter. All these things we saw in the experiment. Now we directly come to the observations. What are the observations we required? Come to the observation. Here I already mentioned there is a four setup is there: sudden expansion, contraction, bend, as well as the elbow. Now come to the sudden expansion. Here it is the observations is there. This observation should be node on from the experiments itself. See area of the collecting tank. All these observations is available in the experiment itself only. Now we're going to show that one. Okay, this is the specification. This is the specification board that is attached to the experiments. All the specifications of each and every experiments is attached to the corresponding experiments. There you can note down the observations. There is no need to buy at the things. All the specification of the experiment is available and the just attached to the corresponding experiments. For the expansion, here it is clearly given for smaller diameter half-inch GI pipe, larger diameter 1-inch GI pipe. That is also given in the millimeter also 16 mm and 27 mm. This can be used for what calculation purposes. Here it is given area of the collecting tank is 0.12 square meter. So this is the specification is attached to the that corresponding experiment. Now come back to the that once you collected the observations, next is what the calculation part. Sorry, tabulation part. In this tabulation, we know that only the two reading is required. One is the manometer reading, another is the time taken for rise of 10 centimeter water in T seconds. Only the two readings is required. Once again, I'm going to show where we have to take that one. I already explained in the experiment. Here also, once again, I'm going to show that one. See, this is what YouTube manometer. In this one, how much the difference will becomes? How much? Hmm. Here, here this is the reference level. Once you give the flow, there you will get the pressure differences. See how much the pressure difference will becomes. That should be noted on. Okay, this is the pressure difference in the YouTube manometer. And once you note on these things, the second reading is from the collecting tank. In collecting tank, what you have to do for 10 centimeter height, for rise of 10 centimeter height, for rise of 10 centimeter height, how much the time is taken that should be calculated. Means to rise 10 centimeter of water through this scale, how much of the time is taken in the water. Stopwatch you should be note on that one. Only the two values should be taken. So this is the manometer reading you are taking in the centimeter that should be converted into the meter, and the time taken is taken in the seconds. So the remaining to calculate the things, that is what available in the equations are available in the manual itself. What is the actual velocity, head loss, everything is can be calculated likewise. Okay, the same tableau column for sudden contraction, bend, as well as the elbow. Here elbow is not included, but up to the bend, the calculation will be the tableau column will be the same thing. Come to the sudden expansion calculation. See, actual head loss means 12 into x divided by 100. This x means this is the reading taken in the manometer. That should be taken in the centimeter. Substitute here, divided by 100, that will be converted to the meter. Next, Q actual. Q actual means area, this is the A means area of the collecting tank. H is the 10 centimeter height. 10 centimeter height, that is the water rising level in the measurement tank, 10 centimeter. And how much time taken, that should be taken here. So you will get the Q actual. Once you know the H actual and Q actual, next you have to find out the velocity of inlet and velocity of outlet. Actually, this is the velocity of outlet, V1 and V2. See, this is sudden expansion means what? Likewise, A1 means the corresponding A1 at this section. A2 means corresponding section at this section. This entry section, this is the 1 and this is the exit section 2 2. A1 means sudden expansion. A1 means what? This position. A2 means this position. Calculate the corresponding area. We know that D1 and D2, that is taken from the specification panel. Substitute here, you will get the V1 and V2. Already we calculated the H actual, what is the head loss, and the H theoretical can be calculated by using V1 minus V2 square by 2G. Okay, this is what the calculation part. This is the things only the calculation part. Next, coefficient of losses can be calculated by what is that what you calculated the H actual divided by H theoretical, you get the coefficient of losses. This is about the calculation part of the minor losses. The same thing should be done for the remaining cases also. Sudden expansion, sudden contraction, the equations are there. But here the theoretical head loss, the equation will be changes. But calculating V1 and V2 the same thing and corresponding cross section. Now come to the bend. Here V1 is equals to V2 because the bend is like that. The bend is like that. Bend is like that. So here same diameter is there. So V1 at this point and V2 that point is the same thing because the diameter is same thing. D1 and D2 here is the D2. So the diameter is same thing. So D1 is equals to D2, that is equals to A. Here we'll get the V. Theoretical head loss can be calculated by K into V square by 2G. This small letter K. Okay. So this is about what the calculation part for the minor losses in a pipe. Okay, thank you.